about the natural greenhouse effect. Now, sometimes people say natural greenhouse effect. Wait a second. I thought it was caused by humans. Actually, the greenhouse effect is both natural and changed by humans. So the natural greenhouse effect has kept the Earth at a reasonable temperature. Otherwise, it would have been frozen over. The oceans would have been frozen over millions of years ago. So let's try and understand the natural greenhouse effect first so that we can see what humans are doing to change it. The greenhouse effect traps heat. The sun radiates visible light. Remember, I said to practice the words visible light so that you won't forget that that's an important technical term for what's coming from the sun. So mainly visible light. Of course, the sun also radiates some near infrared, but that's less important in the greenhouse effect because of the atmosphere interfering with some of that near infrared. But the visible light passes through the atmosphere. Remember what we said about the word transmit? Visible light is transmitted through the atmosphere, or the atmosphere transmits visible light. It allows it to pass through. Think about the atmosphere. The atmosphere is invisible. When you look around, you see right through the atmosphere because all of the gases in the atmosphere are not visible gases. That includes two gases in the atmosphere, water vapor and carbon dioxide. Both of those are greenhouse gases, and you can see that they are invisible. You can see that they're invisible because you can't see them. Visible light passes through the atmosphere and hits the Earth's surface. The Earth's surface absorbs that visible light, and that causes the surface to warm. I want you to think about bare feet in the summer on asphalt. That's too hot. Okay, the asphalt is dark in color, it has a low albedo, it's absorbing a lot of visible light, and that light gets turned into heat. So the visible light turns into heat as it gets absorbed at Earth's surface. Now, because the Earth gets warmed up by the sun, the Earth radiates far infrared radiation. So visible light comes in from the sun, and you notice the short wavelengths here. Far infrared are longer wavelengths, and that's leaving the Earth's surface. And it turns out that far infrared is different from visible light in terms of the greenhouse gases. The greenhouse gases do not absorb visible light. They are invisible gases. But they do absorb far infrared rays. So here are three greenhouse gases: carbon dioxide, methane, and water vapor, and those gases are absorbing the far infrared rays that are coming from the Earth. Do you remember when we talked about the layers of the atmosphere, we said the troposphere is warmed from below by the greenhouse effect, because the Earth's radiation is being absorbed by greenhouse gases in the atmosphere, especially near the surface, because most of the gases are near the surface. Remember, the pressure in the atmosphere is the highest close to the surface because there's just more gas down here near the surface. So the greenhouse gases are absorbing far infrared radiation, and then they radiate that back outward because they've warmed up, and then they radiate far infrared rays out in all directions. So they're absorbing and then re-radiating, absorbing and re-radiating far infrared radiation. Greenhouse gases did not absorb the visible light, so that allowed the light in, but the greenhouse gases are not allowing the far infrared rays out, and that means the greenhouse gases did not absorb the visible light. Notice the visible light passed right on through them. Here the greenhouse gases are present here too, but they're invisible gases. The light passes right through them. The far infrared then is absorbed by greenhouse gases, and some of it goes out into space, and some of it sent back to Earth's surface, and that's what traps heat. So the heat is coming from the Earth, and the greenhouse gases are trapping that heat. They're letting the light in, but trapping the heat. Now let's use our words that we learned: absorb, reflect, transmit, and radiate. Some of these are part of the greenhouse effect. One of them is not. Okay, so the atmosphere transmits the light. The Earth absorbs the light. That causes it to warm up. The Earth radiates far infrared radiation. And the greenhouse gases absorb and re-radiate the far infrared radiation. Now notice which word we did not use in the greenhouse effect. The word reflect. Okay, the reflection has to do with albedo, and the light that gets reflected is not being part of the greenhouse effect because it's just still light. It goes right back out through the atmosphere. Now, some people think that the greenhouse effect is just something that you can measure in a laboratory, but it's not real for the Earth. That's untrue, and we can see that from satellites. So here's some satellite spectra. In other words, a couple of spectra, showing you the energy coming from the Earth and showing where different greenhouse gases are absorbing that energy. It depends on the temperature. Here we are in the tropical Pacific, and here we are in Alaska. We're detecting the radiation coming from the Earth over the tropics by satellite, and we see that a bunch of the radiation is being absorbed by some gases. Those are greenhouse gases that are absorbing that radiation. Each of these curves has to do with the temperature of the Earth at that location, and then the fact that some parts of that curve are absorbed, are disappearing, or lower numbers, is because the gases are absorbing those. These are wavelengths where greenhouse gases are absorbing Earth's radiation. Okay, so these are two different temperatures, 80 degrees and negative 19 degrees Fahrenheit, or 300 kelvins, or 245 kelvins, and those numbers are the temperature of these two different places. You'll notice that we get different amounts of absorption of the radiation depending on what the wavelength distribution is in the atmosphere. So certain wavelengths are absorbed by greenhouse gases, other wavelengths are not.